2018 Audi A4. So on this one, it was just in a slight fender bender. It just damaged the fender and the fender had to get replaced. But the air conditioning line is actually right behind the seam right here. You can actually see it. See that line right there? That's the air conditioning line. So it was damaged by just being hit a little bit on the fender, and it had to be replaced. And if you look underneath before they put in the skirt, this is an internal heat exchanger line. So the suction line is on the inside, the liquid travels on the outside. So it's a pipe within a pipe, and the pipe on the outside actually has fins in it going all the way around. And you come up here, and you can actually see where it comes out at, right there. That's the liquid going in, and then you see the size of the suction line there, and then you see it get thicker because it's a pipe in a pipe, and it subcools the hot liquid from the condenser to add capacity. And it comes back out here, and you can see where the low side hooks into. If you follow it going all the way down, you can see this low side line going in to one line. There's your suction line, and the high side and low side come in and out of it right there, and then the high side separates off again, and now it's a super subcooled liquid where you see this black line in going over there. That's going to feed the expansion valve that comes out of the suction line, and you can see the size of the suction line gets smaller again as it comes out of the evaporator. And that happens right about here in the middle of the car. And this is a clutchless compressor. There's no clutch on it. Right there. That's constantly spinning. And our oil, let's see if we could zoom in on the oil here. And I see somewhere right there. See if we could zoom in on that. There we go. And this one is ND12. You can see it down there at the bottom of the label. So that is ND12. And the label for this one, okay, where's our air conditioning tag? Oh, there we go. And there's the label for this one right here. 525 grams. And I got it down to 480 microns right now, and it's, yeah, you can see it's jumping up. That's moisture bubbling up, maybe a little trap refrigerant. This was from several days ago, and unfortunately, most likely, you know, the system was open to the atmosphere, and this is PAG oil, and it's hydroscopic like POE oil, and so I got quite a bit of moisture most likely trapped in there, and that's why I keep getting it bouncing back up. There's nothing you can do about that, because once it's open to the atmosphere for a long period of time, you cannot remove all the moisture just by throwing a vacuum pump on it. The desiccant material was not changed. That was the first thing I asked when I came in the shop. I go, well, the condenser was not changed, but I asked, was the desiccant material changed? And no, the desiccant material was not changed. And I'm just inspecting the condenser, and if you look really carefully at the finning on that condenser, let's see if I could zoom in on that. I'm going to try to zoom in on the finnage, see if I could focus. Do you see that finnage? How many fins per inch? That's about 21 fins per inch. That's a tight condenser. So unfortunately, sometimes after a body shop gets to it and the insurance company says throw in a cheap aftermarket, it ends up being, oh, I just noticed my video is in the wrong direction. Sorry guys, I screwed up. Oh well, I'm not going to retake because I don't have time. But if you look at the fins per inch, that's a 21 fin per inch. And if you get a cheap aftermarket condenser, it'll probably be a 16 fin or 18 fin per inch condenser. Alright guys, I'll see you later. That's about it on this, because I got to get moving. Unless something out of the unusual, ordinary happens, maybe I'll show you some more superheat subcooling, which will be really messed up because you can't use it on this vehicle, because this has a heat exchanger, a line heat exchanger, and there is no way for you to get one of your crimp-on clamps at the evaporator. It's just not happening unless you're going to take off this whole plastic piece, and hell no. That's all I gotta say. So I'm taking the superheat after extra heat gets added to it from the liquid line down here, because this is where I could get a hold of easily, and that's just how it is. Sometimes I'm lucky enough where, when depending on the size of the accident, they'll have that plastic cover up, and then I can take my thermistor clamp and I could get right at the expansion valve, right after the expansion valve, right out of the evaporator, and I can take my superheat before and after the internal heat exchanger. And you can, and when you can do that, just kind of learn how much drop a heat exchanger drops for different types of vehicles, for different temperatures. We're at a low ambient temperature. It's only about 64 degrees right now, but it's like 97% humidity. And so you'll start to learn after you do a couple hundred heat exchangers on different, because they'll be different from, say, a Chevy, an Audi, a Volkswagen, a Toyota, a Hyundai. And so just keep taking the temperatures of before and after the heat exchanger and start learning what an average drop is, because unfortunately they don't have pressure taps. So if you look right here, you have your pressure or your high pressure after the heat exchanger. Well, it'd be really nice to know if you had one before a heat exchanger, if you had anything wrong inside plugging up of a heat exchanger. But if the plugging up was coming from a condenser, most everything out of the compressor, most everything that would plug up in the condenser. So it would make no difference. But it would be nice if you had a high side pressure fitting coming out of the compressor, so you could take the drop of the pressure at this point before it goes into a condenser, and then you had another high side fitting coming out of the condenser, so you can see a pressure drop across the condenser. But of course they don't do that for us, so you have to take temperatures, and you only could take temperature readings correctly on a full charge, not a partial charge. Getting to know the temperatures of your refrigerant lines coming out of the compressor, going through a condenser, then you get the condenser drop, and you would take that pressure right here before it goes into the heat exchanger, and then again just as it goes into the heat exchanger right there, you can take the temperature again, follow the heat exchanger, and if you could get a hold of it, which you can't on this one down there, you can start to actually get a feel of what the temperature drops through different devices like a condenser and a heat exchanger should be. Alright, I'm gonna fill this one up. Enough blabbing. See you guys.